Here are some more home building education series videos. Let's go ahead and get started with our first one. Here is another video in our garage building series. And in this one, we are going to build 2 apartments over a 2-car garage and actually put a walkway around the building so that we can get up to our first level and then up to the second level. And we're going to have a gable roof. And of course, the gable roof is going to have a large attic. And I went ahead and designed the stairs like this. However, in the next video, I am going to provide you with a different example and a reason why I did it this way. And of course, the reason why I did it this way would have something to do with saving a few dollars. And in the next video, I will fix the roof. And for those of you who cannot see what is wrong with the roof, you will hear in a few seconds. And that will be the fact that the roof overhang could hit you in the head if you are just a little bit over 6 foot tall. However, you might not have known this if I didn't show it to you in the video. And again, that will be something I will be fixing in the next video. And for those of you who watch my videos regularly, this video is not meant to provide you with structural engineering information. And local building authorities and engineers might need to get involved in this project so that it doesn't fall down in case there is a small tornado, earthquake, or the big bad wolf comes along with some strong wind. Now the lower deck is going to be dropped a little bit along with the upper deck. And in this example, I have the corners mitered and the beams are sitting on top of a post. That might require some building hardware, of course. And in this example here, I went ahead and ran the beam all the way over to the next joist. However, you can stop it at the end of the wall here. And of course, that is what we did on the other side. And the drop here is just a little bit less than 2 inches. And this is actually a question I received today. The individual wanted to know what the maximum or minimum was for dropping a landing at a doorway. And even though the standard for this measurement has always been around 2 inches, I've noticed that some of these building codes have changed and might be 1 inch or less. And of course, our floor framing with 12-inch on center joist, our floor sheathing, and our walls. And in the first apartment, we will come into a living room. We'll have a bathroom, a kitchen, closet, and a bedroom. And let's go ahead and take a quick tour of this. And I've actually made a video on this one already as one apartment over a garage. You can always check that one out. And I have already done the plumbing for this one also. So make sure that you check those videos out, and they should be on our playlist and can be found at our website by clicking on the garage link. Another thing we will be doing will be to leave a 2-inch gap in between the outside of the wall framing and the outside of the stairway. And this will allow us to run our siding or our stucco behind the stairway and to avoid waterproofing the edge of the stairway. So again, a 2-inch gap here. And since we will not be nailing this stringer up against the wall, the stairway won't be as strong. So again, it's one of those things where you might do one thing to save a few dollars, but create other problems. And of course, the step down here is about 1 inch. We are using 1 1/8" subflooring here, along with 2x6 decking. Next up, let's take a look at how the stringers are attached to the beam here. And if you notice with the lower stairway, this measurement here is going to be a little shorter than the upper measurement, and I will explain that when we get there. And of course, this area here will need to be waterproofed, and I will try to address this in a future video. If I forget, feel free to remind me. And the upper stringers will sit on top of the decking. And again, we will have a 2-inch gap here. And for those of you wondering, well, how are they going to install stucco or nail the siding with the stairs in the way? Well, you're probably going to have to install that before you install the stairs. And again, that could create another problem like I was talking about. We solve one problem but create another problem. And the upper stairway stringers will be connecting to a cantilevered beam, and the deck will have 3 cantilevered joists that go back into the floor, along with our step down here. And sometimes it will work out if you use a smaller beam, and the beam will simply drop down in the floor. and won't be flush with the top of the floor joist. So another thing to consider when building a project like this. And all of the joists except for this one are sitting right next to a floor joist. And the reason for that is so that I can nail the heck out of this joist and get a nice connection into the beam here and into the joist. However, this one needed to move over a little bit, so I used some spacers. So again, another idea that you might consider using along with your 16D nails. And I would imagine you could always run some bolts through this also. However, I don't know if that would be necessary. Another view of the drop down or the notch in the beams and the joist. And in order to have the beam next to this joist here, I needed to extend the upper section of the stringer here and had to make it about 2 inches longer. Otherwise, the beam would have been over a little bit and I wouldn't have been able to nail it into the floor joist. Next up, let's go ahead and take a look at the blocking here. And we're using the blocks here instead of a doubler. So usually a double joist is required underneath any walls that run parallel to the joist. However, in some cases you can install blocks, and something like this might save you a few dollars. Next up, let's go ahead and install our walls without the sheathing so that you can get a better understanding of why we're installing the blocks. And of course, the blocks are going to help to support these walls, whether they are load-bearing or non-load-bearing. And there's no need to install blocks with the walls that run perpendicular to the joist because they are going to be sitting on top of the joist, where a wall that is parallel to it might not be. Next up, let's go ahead and install our floor sheathing. Pan out here. And we had to rearrange the floor up here. The living room is now over here. And I went ahead and I left the closet here, kitchen, bathroom, and bedroom. However, I understand that this wouldn't be a common design. But in such a small building, it's probably not going to matter that much if you have to walk from the bedroom to the closet and then back into here. But I do understand that some people this will not be acceptable. And again, if you don't like this design, you might like it because it's going to save you a few dollars when you install the plumbing, because the kitchen and the bathroom will be stacked over each other. So again, another design option there. And let's go ahead and take a tour of the upper apartment. And our bathroom window, I went ahead and designed this one a little different than the one below also, or should I say the framing on those. Next up, let's install the ceiling joist with our crawl space access hole and our roof rafters. And if you're looking for more information about the roof rafters, you will find it in the video that I already made. And to find that video, you would just need to go through the playlist and look for a roof like this with the word, I believe, apartment in the title, and you should find it. So there we have it, a building with 2 apartments and 1 2-car garage. Here is a video that will be helpful for anyone who needs to figure out the post height that will be supporting a ridge beam for either new construction or even remodeling. And the height of the walls will not matter because we will be adjusting for them depending upon whether or not the post goes all the way down to the bottom plate on the first floor framing or whether it is going to be sitting on top of the floor sheathing like we have here. And in order to do that, I'm going to use a string. However, most carpenters aren't going to use a string. They're just simply going to measure from one point to another point and then do their calculations. However, if there are any variations in the concrete footing or any part of the framing, then you could end up being off a little bit depending upon those variations. And something that might cause those variations would simply be assembling a section like this with multiple pieces to where on one side of the building you might end up with a section without any gaps in it at all and really tight framing. However, on the other side you might have a gap between the bottom of the plywood and the top of the joist. And something like this can create problems when you're going to be using more than 2 posts or trying to make everything work perfectly. So the first thing on our list we will need to accomplish will be to gather some type of a reference point. And in this case, it will be from the string to the top of the bottom plate. And this measurement should be the same for the walls on each side. Now, even though you wouldn't have done this yet, let's just go ahead and run through some of the measurements that I have already created from our scaled model, including what the rafters would look like. Take a look at the bottom, and this is very important here because in order for the method that I'm going to show you in this video to work, the bottom measurement here, or the plumb measurement, will need to be the same at the bottom as it is at the top. And if it isn't, and you are going to make it different, then simply subtract the difference or add the difference to the height of the post. And another thing I want to point out, we are not going to be going to the center of the post with this one. However, we will need to figure out the position of the post and where it's going to be located. And in order to do that, you're going to measure the overall span of the building. Because keep in mind, none of this stuff is going to be here. So measure from the outside to the outside and then divide that measurement by 2. And then subtract half the thickness of the post, because the post is going to be located in the center of the building. And then once you have figured out the location of the post, you can go ahead and measure from this point to this point, which will be the same as from this point to this point. And then this is the number right here we are going to use to calculate the height of this distance here, or the distance from the top of the string to the top of the ridge. So let's go ahead and break out our trusty calculator. And the roof pitch we are going to be using will be an 8 and 12 roof pitch. So the first thing I want to do is multiply 9 times 8. Because for every 1 foot we go horizontally, we're going to go up 8 inches vertically. So let's multiply 9 times 8 to give us 72. And then you can go ahead and write that number down on a piece of paper. And then in order to convert the 10 1/4 inches to a decimal that will represent feet, we will simply divide 10.25 and then hit the divide symbol, and then we're going to divide that into 12. And then we're going to take this decimal here and then multiply it times 8 to give us 6.83. And 6.83 is going to be somewhere between 6 3/4 and 6 7/8 of an inch. Now if I add 72 to this, I'm going to get 78.83, or 6 foot 6 7/8 inches, providing us with the difference between the top of the beam and the top of the wall framing, and the measurement we need to calculate the overall length of our post. And in order to do that, we can simply add these two numbers together to provide us with the overall height, and then we can go ahead and subtract the height of the ridge beam from that measurement to get the height of the post. And to figure out the post height on the other side, all we would need to do would be to measure from the top of the framing plate to the top of the bottom plate, or the section that the post is going to be sitting on. For example, if the post was going to be sitting on top of a post base connector, then we would be measuring from the top of the post base connector to the top of the framing plate or the top of the string, and then adding the difference that we have calculated here to those measurements to find that post height. And we could do the same with the post in the center by using a string or measuring from the wall framing, or we could simply use the measurement for this post here and add 1.5 inches to it, or add the thickness of the wall framing plate to provide us with the length of this post. And if this was going to be a full length beam, we could simply install the beam first and then measure the post. And that, my friends, is how I would figure out a post in the center with a full length beam. And if all of that makes sense, then you can stop watching right now. However, for those of you who need a little more information, or you're looking for an example that starts without a roof, or any posts or any rafters, let's go ahead and start with this. And since we need to figure out the point from the post to the outside of the wall, as I mentioned in the video, we will need the overall length of the building. And this measurement will be from the outside of the wall on one side all the way through to the outside wall on the other side. And then we're going to divide this number by half so that we can find the center of the building. And the center of the building is also going to be the center of the post. However, it will not be the measurement that we are going to use, because we're going to need to subtract half of the width of the post. So if our post is going to be 3.5 inches, we're going to need to subtract half of that, which will be 1 3/4 inches. And this is the point of reference we are going to use to figure out the difference in the height of the top of the wall framing where the rafter is going to be sitting on top of, and the top of the post where the other end of the rafter is going to be sitting on top of. Next up, let's go ahead and make things a little simpler by getting rid of the building and then starting with a 4/12 pitch. So what I've done here is used my scaled model to figure out the difference before I break the calculator out. Now this is a 4/12 pitch, which means that we're going to take the number 9 and multiply it by 4. And then we're going to write this number down on a piece of paper. Now we're going to clear that and then take 10 1/4 inches, which as a decimal will be 10.25. And then we're going to divide that by 12. And this decimal here will represent 10 1/4 inches in our measurement. So I'm going to take this number here and multiply it times 4. And then add 36 to it. And I'm pretty sure this decimal here is going to convert to this number here, almost right on the money, and provide you with an example of how you can calculate a roof that is going to have a pitch with a 4:12 ratio. Or for every 12 inches of measurement, we're going to go up 4 inches. Or for every 2 feet, we're going to go up 8 inches. And 3 feet, we're going to go up 12 inches. So that ratio can be used to calculate the height that we're going to need to figure out the length of our ridge post. In this video, I will provide you with the top 5 stair building codes, in my opinion, that you will need to be aware of when building a set of stairs with a landing. And the first one on the list will be the minimum width of the stairway, and that will be 36 inches. Now that is 36 inches after everything is finished, after the drywall has been installed and after any of the wood trim has been installed. So if you have a stairway that is going to be in between 2 walls, then you might want to allow for anything you're going to be adding to the side of those walls, like drywall, wood trim, or skirt board. Next up on the list will be the minimum headroom height. And that line will be measured from this line here, or the front of each step, but it will not be measured from the top of the step on any other part of the step. Again, it's going to be measured from this line here. You're going to go straight up plumb or vertically level. And again, it can be measured from the front of each step or from this line here. Next up will be the individual vertical rise. That will be a maximum. It cannot be larger than 7 3/4 inches. And I would strongly suggest that you check with your local building authorities, building departments, because they might not be using the codes from the 2021 International Building Code book. Next up, the minimum tread depth will be 10 inches. However, when I first started working, it was 9 inches, and the vertical riser height was 8 inches. Next up, let's go ahead and take a look at the minimum width or depth of the stair landing itself. And according to these building codes, the depth of the stair tread will need to be the same or larger than the width of the stairway. And that would be the same for the top or the bottom. So the depth of this landing here will need to be the width of this or larger. And this was something a long time ago that used to have a 36 6-inch minimum, which would be the same as the minimum width for a stairway. However, they have changed the verbiage on it. So again, these building codes are from the 2021 Residential Building Code book. And for the most part, these are building codes I like. However, if you do not like them, then check with your local building department to see if they have different building codes that might work better for your project or for you personally.